In this class, I'm going to really stress reading, learning how to read a dense technical text. I think that's a really valuable skill to have, and if especially as you can see with our pandemic and all that, the more independent you are, the more you can just pick up a text and glean information from it, technical information in particular. It's going to be a really valuable skill, really valuable in college. Um, and so I'm really going to be stressing that this year. We're going to be using a flipped structure for our class where I'm going to have you read ahead of time so you get the basic physics from the reading at home. And then you'll come in and ask questions, and I will clarify that. I will not be going over the reading though. So I will only be answering questions if you have questions on the reading. If there are no questions, then I assume everybody fully understood it, and we're just going to go ahead with problem solving in class. So make sure you're doing active reading. Active reading is different than maybe you're used to. You want to make sure you're not laying on your bed or something like that, or just lounging somewhere. You want to sit down, you like I am here. I got a desk, I got light. You're going to need paper, a pencil, and a calculator. You're not going to be getting a lot of pages necessarily of reading, but it's going to be dense, right? There's going to be a lot of technical things, and if you just read the words, you're really not going to be able to make much sense out of it, and that won't be of any value. So let's take a look at what I'm expecting you to do. One thing, I want to make sure you don't just kind of blow off all the rich things that are in the text that are really important, that people, when they're reading, they tend to just, oh, I read that paragraph, blow off the diagrams, blowing off all this other stuff like looking ahead and back and stuff like that. This is all really valuable stuff. And you really want to focus on these little tips that the author is giving you. So when you're reading, well, for one thing, when you start reading the textbook, you're going to want to start at the beginning. I know most people probably don't do this. More advanced readers do this. When they get a textbook, the first thing they look at is a table of contents, and they see what are we going to be covering, what is this, what is that, and you go through and you get an idea ahead of time of what you're going to be dealing with. Once you get to like the beginning of a chapter, it'll have a title. Read the title. Try and think about what does that mean. Motion, you know what it means in one dimension. What does that mean, one dimension? Think about it. What does this mean? Motion in one dimension. In this case, it means going in a straight line, but make sense of the words of the title. And then they got looking ahead here, and they have uniform motion, acceleration, free fall, and they talk about it, and they got little diagrams. So that's what we're going to be learning about. So you have an idea of where we're going with this. And then looking back is really important. This talks about stuff you're going to need to understand the new stuff that we're reading about. So it's really important if you look at this. And so here I got looking back, and it says motion diagrams. If I don't remember what a motion diagram is, I better get refreshed. It has a description of it, and it also tells you what section it's covered in. So you better go back. If you don't remember this or understand it or can't work with it, you better go back, because in this course, everything builds on everything else. We don't just do something and then walk away from it. We just build and build and build and build. And if there are any pieces missing, you're going to struggle. So make sure you're doing that. Make sure you're not blowing off that. And the stop to think things, these are really useful. These are little questions to just check your understanding. Make sure you're doing those. And it's going to ask you a question. There's going to be multiple choice, and choose. And the answer, of course, is in the back. Also, when you're looking at the text, you've been at this long enough where you should know that very often in the back of the text, there are answers to usually to odd questions or something like that. Check to see what's in the back of this. Are there? What else is in this text? Oh, look at that. We got all kinds of tables and things like that. Of course, we always have an index. And there are answers. And just make sure you're just familiar with what's in the textbook. This shouldn't be a surprise. Most textbooks have something like that with the answers. They don't have the solutions. They don't explain how, but they at least give you the answer, which might be useful. All right, so you're reading, right? So you're reading through, and you have I have my notebook here, and I'm just gonna write, this is my chapter 2, and I'm gonna motion in one dimension, Now, your reading log here is just making sure you're an active reader. You're thinking about all the words and all that, and it is not so much a document that is meant to be overly pretty, to be handed. It's not a report. It is just making sure that you're being an active reader. Passive reading in physics is of very little to no value. So make sure you're doing that. So section 2.1, all right. So I'm going to write 2.1 and describing motion. All right, so I read that, and then you'll notice every once in a while you'll see a word that's bold, and that's going to be a word with some vocabulary that you may or may not be familiar with, and it's going to be an important word. So the branch of physics that deals with the description of motion is kinematics. All right, I never heard that word before, so I'm going to write it down, kinematics, and I'm going to write the definition, right, of kinematics, because they gave it here, and it is the branch of physics that deals with the description of motion. And then I'm going to be reading representing motion, and it referred to here that, as we saw in chapter 1, kinematic variables such as position and velocity are measured with respect to a coordinate system, an axis that you impose on a system. We will use x-axis to analyze both horizontal motion and motion on a ramp. We will adopt the convention that the positive end of the x-axis to the right. This convention is illustrated in figure 2.1. Now you want to spend time on figure 2.1. It's important to understand that. I'm going to come back to that in a little bit, but right now I'm just going to look at it. Design conventions for position. Position to the right of the origin. All right, here's my position. Here's the origin. It's to the right, so x is greater than 0. Okay, that makes sense. I learned that in math class a while ago. And here I have position to the left of the origin is, all right, and that's negative. Yeah, all right, number line. I know these are all positive numbers and these are all negative numbers. All right, I'm good with all that. And then they do something with y. All right, that makes sense. The convention, all right, so then you just keep reading along, and you should be making sense of these things as you go. And make sure you're spending plenty of time making sure you're understanding what do these figures mean. Don't just go, I don't know what that means. It might take you a while. You could easily spend an hour on a page in physics, right? You may not. It depends on how dense it is, how difficult it is to understand in that topic. So don't set a time limit on your reading. Don't say, well, a page should only take me a minute or something like that. It doesn't work that way in physics, right? It might work that way if you're reading a novel or something like that. That's a different type of reading. So anyways, you go through and you read it. Make sure you're spending a good amount of time understanding the examples. And in fact, what I want you to do is you should always have a Post-it handy with you, a bunch of Post-its. And as soon as you hit you got a conceptual example, what I'd like you to do is take a Post-it and cover up the solution. So the example is going to have some sort of question probably. And it says, the graph in figure 2.5, there's figure 2.5, represents the motion of a car moving along a straight road, right? I'm going to cover up the rest, everything else, I don't see it. Describe in words the motion of the car. All right, so they got a position versus time graph, and I'm looking at that, and okay, so what is happening? Let's see. It's starting at 10. I might draw a diagram. I might draw a picture. So I got a car like that, and it's going to the right. It's starting at 10. Here's position 10. And then it goes to 0. Here's 0. And then it goes to negative 20. All right, so it's going like that to the left. So it's starting off moving to the left. All right, so I'm making some headway with that. Maybe you'd look at that and you're completely baffled, right? Maybe you're completely baffled. Maybe you can go back and take a look. If you've gotten to the point where it's like, I just don't know what to do, the fact that you tried, the fact that you attempted to solve this problem means that you internalize the question, right? So now when you look at the solution, it's going to make more sense. You're going to get more out of it. So now let's say I failed miserably, which very often you may, and that's fine as long as you learn from it. So now you're going to read this and go, okay, all right. So hopefully you go through, you read it, you go, oh, that makes sense. So now I go on and I read more, and I'm reading my thing, all that stuff. Okay, so let's say I got to the end of my reading. I went through, I actively read, a velocity versus time. I know what that is. You wrote down any definitions that you didn't know that you think are important. And let's say I get to the end of this section. All right? Now, let's go back. I just read it. So when you're reading physics, you don't just read it once. You're not going to get it for the most part. You want to reread. At least reread again, at least once. You really need to reread until you understand it. That's the goal. The goal isn't time. The goal isn't that I checked off the box. He said, read it, so the words went in my eyes. No, it's understanding. So you're reading for understanding. So now I'm going to go through again. And what I'd like you to do, I think this is really powerful here, with my Post-it, for every figure, I'm going to try and recreate the figure. I'm going to cover up what the figure is and read the description. It always has a description. So sign convention for position. What are they even talking about? What are they asking? Oh, sign convention for position. Oh, okay. So now you struggle with this. Maybe you can draw it. Maybe you can't. If you can't, you eventually go through and go, okay. And then maybe you want to draw it. So look at it, make sense of it, cover it up again. Let me draw it from memory. Don't copy it. You're not doing any good copying it. That's no good. Copying's not good. You got to internalize this stuff, right? So you got it. And all right. So I wasn't able to get that accomplished. I wasn't able to do that. Fine, right? Maybe I can get the next one. Measurement of position at school, walking school. Okay, then they graph. We got to graph this. Maybe I can, maybe I can't. So I go through and I do all these again. And some of them I was able to do, some of them I was not. Now, what you want to do at a later date, not necessarily right away, because you don't really want to go from memory. So you're not just recreating a picture in your mind. You're using the ideas and drawing a picture from the ideas. So now at a later time, maybe later that evening or something like that, or another day even, you're going to cover that up and see if you can write down the sign positions for sign conventions for position. Same thing on your example problems, right? You tried that before. Now let's see if you can do that by reading. Make sure you're not just memorizing the answer and spewing that out. You're not doing yourself any good. Don't waste your time. You got, right? Take advantage of your valuable time. All right. So you're going to go through, you're going to recreate the diagrams in your reading log, and you're just being active. You're going through and trying to understand every piece. Some things you'll have more success with than others, and some you won't understand at all, in which case you need to make a note. Write it down and say, I need to ask Mr. Belling this question in class because I don't know what position is. How could I possibly know what position is? That's crazy talk as far as I can tell, right? So write it down and then bring your reading log to class and then ask questions. Because I'm going to start every class with any questions on the reading, right? If there are no questions, we're moving on. And then you're left behind if you had a question and you didn't ask it. Make sure you're being your own advocate. All right. So there you go. That's active reading. And you're going to be turning in these reading logs. If they're super neat and the problems are all worked out really neatly, I know you didn't do it. That wasn't active reading. It should be a mess. I should see failures. It's not just, if I just see it real clean and it looks like this, okay, you copied that. You did yourself no good. You're wasting your time. You're wasting my time. No, this is work here. This is all work. You should be handing in work. It doesn't have to be pretty. It has to be authentic, though, right? So there you go. Active reading. Your reading log. The goal of this is to make sure you're actively reading. This isn't necessarily going to be good for studying for a test, right? Because you're going to have everything down. When you study for a test, you want to be able to focus on what's important. When you're first reading something, you don't understand what's important because you don't have context yet, right? You only know after you have some context what's important. I'll give you a clue what's important. If you go to the end of every chapter, which you should know by pretty much now, any technical textbook, they will have some sort of summary, right? And whoever wrote this textbook thinks that this is the really important stuff, right? So make sure that you're solid on these. You need to know the details. It doesn't go into heavy detail. The heavy details in the reading. You need to know the detail. The devil's in the details. So anyways, there's our reading logs. We're going to be doing that for everything we do. I'm going to have you read ahead of time. Active reading logs. I'm going to need to see those. You'll struggle at first, but as you go, you'll get better and better and better. And hopefully you'll be able to develop a strong ability to read dense technical texts. I've had many students thank me for having them do this because they needed it in college, right? Because, it's real easy to make it through high school without ever developing the ability to read a dense technical text, but you're going to need it in college if you're going into any sort of technical field. So, anyways, good luck with your active reading.